Okay guys, we're at the end of our first week of remote learning and remote lessons. This is a lesson on equations and graphs of these parabolas. We're going to come up with equations of these parabolas. So remember to always start off with either printing out this handout, or you're going to have to draw these pictures, which means you're going to take some time and you're going to need a graph paper because we need to look at points on this graph. So where you can do it without printing it out, it would be helpful if you could, but I do understand that you might not have access to a printer. But still, graph this on graph paper. So pause the video and graph this carefully, or from your blanks that you have available to you. So put your name and date on the paper. And then what I want you to do is notice right here, we're picking points A, B, and C, and I'm looking at this distance from A to the directrix. And we talked about this in our last lesson, that this distance from a point on the parabola to the directrix is exactly the same as that point is to the focus, that those have the same distance, which means we can count this distance, that it's 5. And so if this distance is 5, then A to F is 5. So we don't need the distance formula. We can just count this vertical distance, and that is going to be the distance to the focus from that point. So over here at point B, we can do the same thing. We have this distance that goes to the directrix, and it's going to be equal to the distance from that point to the focus. And because we can count this vertical distance, we can see that the length from the point B to the point F, this distance is going to be 10 as well. Now, this last point here, this point C, it doesn't have numbers, but we do know that whatever that distance is, it is the same as that distance right there, which means the distance, hold on just a sec. So the distance from this point to the directrix is the same as the point from xy that is to the focus, -2, 2. And so we know then that the distance from CF is going to equal that y, because that is what this distance is. It's from here to here. But I have another question for you, and that is, well, what if we did use the distance formula for each one of these? What if each time I was trying to find AF, I didn't look at this vertical distance. I didn't look at the vertical distance to B. I didn't look at the vertical distance to C. We used the distance formula. And remember, the distance formula is the x's subtracted, and then you square them, and the y's subtracted, and you square them. Oops, and then and then when you're going to add those two groups, it says a minus, but it should say a plus right there. I say a plus, there we go. And that's going to give us 16 plus 9, and 16 plus 9 is 25, and the square root of 25 is 5, which is exactly what we got right here when we just counted the vertical distance. So it checks out just fine. That's the distance formula. Now let's look at point B. For point B, we counted over here that the distance was 10 when we looked at it, but now we're going to use the x's that we're going to subtract from point B and point F. So we're subtracting the x's, then we square it, then we're subtracting the y's and we square it, add that together, take the square root, that's the distance formula, and we get the square root of 36 plus 64, which is 100, so we have the square root of 100, which is 10, which is exactly what we have over here. So once again, that distance formula checks out. But what about the distance from C to F? What about this distance if I use the distance formula? Well, I'm going to take these points here, these coordinates, x and y, and I'm going to subtract from them these coordinates. And so I'm going to have, for C, I'm going to take x minus the -2, and then the y minus the 2. So we took x minus the -2 of the focus, and the y minus the 2, and squared each of those, and add them, take the square root. But what did we say CF was? Well, over here we see that CF is y, which means that expression must equal y. If I can avoid having square roots in an equation, I will. So I'm going to square both sides of that equation. And when you square both sides of the equation, you end up not with y, but with y squared. And here we was x minus negative 2, but when you subtract a negative, it is adding. And then we had y minus 2. So what were we subtracting from x? Well, we were subtracting negative 2. And what are we subtracting from y is positive 2. And that's what tells me that the focus is what I was subtracting. So I was subtracting a negative 2 and then a positive 2. All right. So in this next problem, we're going to be doing pretty much the same thing, but it's a different parabola this time. So first of all, I notice that I have this vertical distance to this point, and this point is the coordinates x comma y. So I know that that distance is y. And I have this distance here, and I could use the distance formula to come up with that distance. Even though I know that these two distances are equal, I could use the distance formula for this one. So the distance from the point 3, 2 and the point xy would be to subtract the x's and then subtract the y's and square them. So that's what I did. I took x minus 3 and then the y minus the 2, squared those, and then add and take the square root. But this distance here is the distance from the point xy to the line y equals 0. And I wrote this in particular because the distance, it's not just y, it's the distance from y to the directrix, which in this case is y equals 0, which means the distance is actually, which is the x-axis, it's actually y minus 0. We take this y and we subtract whatever the line is at, but that just equals y. So this distance is equal to y, and so I have that there. That was what the question number 1 was asking. How could we write an equation for it? Once again, I don't like the square root in the problems, so I'm going to square both sides. You see I put squaring both sides. That's going to get rid of the square root, and I'm going to end up with y squared. So here now you see I have, this is the way that I like to write it. And this is an equation of that parabola. The point 3, 2 is the focus. And I can see that because what am I subtracting from x and what am I subtracting from y? I'm subtracting 3 and then 2. And that's the coordinate right here, 3, 2. For this next problem, they're saying there's a better way that we like to write them. It just tells us more information. It involves multiplying out the y's. We're going to leave the x part alone. We're going to leave this alone. We're only going to multiply this part out here. So we're going to multiply out y minus 2. Well, that's a binomial squared. So there we have it. Y minus 2 is y squared minus 4y plus 4. The next thing we're going to do is we're going to get our y's all on the other side. So we're going to subtract y squared, and we're going to add 4y. That's going to get rid of these y's, and I'm going to put them over here on the right-hand side. Now lastly, I want to make sure that my y is all by itself. Right now it says 4 times y, so I'm going to divide each part of that by 4. And to divide by 4 is the same thing as saying 1/4. So this is going to have 1/4 in front of this one. I've got a 1, and all I have left there is a y. And so we have 1/4 x minus 3 quantity squared plus 1, and it equals y. Now, we're technically done, except that I don't like the y here on the left-hand side, actually the right-hand side. I want to write it on the other side, which is no problem. We just move it over there. And so there it is. So it's going to be y equals. And now that's exactly the format that they asked for it here. And this tells us some information which we haven't learned yet, but it's putting it in a particular format. This is called the vertex form of a parabola. On the last set of problems, we have these 4 graphs, and we want to match these 4 graphs with these 4 equations. To do that, I want to analyze first, look at this, and you're going to write in your problem set, what's my focus, and what is the distance to the directrix. So in this first problem, I see that my focus is the point 3, 2, and the distance from any point on the parabola to the directrix, this vertical distance, is whatever the y distance is up to that point. So I just say y because y would mean any height. any distance that it has, which is whatever number's on the y-axis. That's how high it is. For this one, our focus is negative 3, 2, because it went to the left negative, it went left 3 and up 2, so that's negative 3, positive 2. And this one's a little bit different because this distance right here, this is not y, because you could even, if I pick this one, I counted up to it, this distance is not the number on the y-axis. In fact, it's 1 less than that because the directrix is 1 unit above the x-axis, which means every single one of these heights, these distances, is going to be whatever the y value is minus 1. So on this particular problem, it looks like it's about 3.5 here, but this distance is not 3.5. You can count it. It's 1, 2.5. This is 2.5, even though the y-axis would say this is 3.5. So it's 1 less. In this third problem, our focus is negative 3, 1. You can see that point right there. We're over negative 3 and up 1. And the distance to any place on the parabola is the distance from the x-axis. So whatever this one, like the height here, it is exactly whatever it says on the y-axis. So that height is y. The fourth picture, the fourth graph, we've got here is a focus of 3, positive 2. And the height, well, we have that same idea here that if I look at this right here, this height, we follow it over all the way to the y-axis, it says 2. Except that if I count this, 1, 2, oh, it's 3. It's 3 units because this directrix is 1 unit below the x-axis. So the distance here is not y, it's y plus 1. So we're going to write these equations, and every time we write them, we just take x and we subtract the x of the focus, so x minus 3, and then the y, and we subtract the y of the focus, which was 2, so we have y minus 2, and it's going to equal this height squared. So there's the equation for this parabola. Now if we go down to this problem here, we say, oh, our focus is negative 3, 1, so I have x, whoops, where am I? There we go. X minus negative 3, quantity squared, plus y minus 1, quantity squared, and the height is y, so it equals y squared. Over here, my focus is negative 3, 2. Once again, I'm going to be subtracting from my x and y these numbers, so I've got x minus negative 3 quantity squared, y minus 2 quantity squared, and it equals the distance from any point there to the directrix, y minus 1 quantity squared. And the fourth one we have here. Subtract your x and your y, and then equals the height squared. Okay. Looking down below, we can see that this equation is A. Down here, it's this one. So that goes there. This equation right here is B. So we can just match it up. We can see here's the equation, and it matches this one right here. Now, this one, because I don't see, in both of these what are left, I've got C and D, and both of these say x plus 3, both of them. But this doesn't say x plus 3, this says x minus negative 3. Well, x minus negative 3 happens to be plus. When you subtract a negative, that's adding. So that is C. And similarly, this one here, when you're subtracting a negative, that changes to addition, and that is D. So that's the end of this lesson. This is the end of your first week of remote lessons. I know some of these videos, they've all been about 14 to 15 minutes long. I hope you've been able to take all your notes and get your work posted. I will be contacting students, checking on the work that you've done, and be emailing you and or text messaging you as we start the beginning of next week. Don't forget to message me any questions that you might have.